Now, as I told you about the states of matter, so likewise, you will be surprised to know that in two forms water occur in nature. It occurs in free form also and it occurs in combined form also, right? In free form, as I have told you, that it occurs on this thing, in the liquid, mist, fog. We have just discussed the solid, liquid and gaseous form in which the water occur, right? So they all are free forms, and the water is found in a combined state as well. So how it is found in a combined state? Some of the salts, like that means, like, you must be familiar with the copper sulfate. When copper sulfate is kept in the atmosphere, what it does, it just absorbs the moisture. So that means water is also occurring in a combined state. And whenever any salt, we have discussed before also, that whenever any salt just absorb the moisture, the water gets, sometimes the water gets chemically combined with that salt, and that water is called, which is present in a combined form, as water of crystallization. So likewise, as I told you about the copper sulfate, similarly we have this thing, the example which is coming in my mind is washing soda. You know what is the formula for the washing soda? It is Na2CO3 10H2O. So here again you get to see 10H2O. That means it also acts as water of crystallization. So we do have the water in the free form, and we do have the form in which the water occur in combined state. So likewise we have the water of crystallization as an example. And moreover, in the plants and animals also, the water is present in a combined state. We get to see the water which is present in a combined state in plants and animals. That means the living organic matter. So that means the water occur in, the states are three, that is the solid, liquid, gas, but the forms are two. It can be in free form or it can be in combined form. So this is how you should know that in which forms and states the water coexist. And also do not forget about the triple point. Triple point is important point at which we get to see three states exist simultaneously, and it is just affected by the temperature and the pressure. So it is not simple that at 273 Kelvin we are going to get the triple point. No, there is a fixed temperature, that is 0.01 degrees Celsius and 4.588 mm of mercury. That means the pressure at which you get to see the triple point of the water, right? So as we have done with this now, so I just want you to make you familiar about the importance. As you all know that water is very important, as I told you that whenever we keep some fast, we are fasting or something like that, if we are not allowed to drink water, we just like we have a feeling of being faint, right? So that means the water plays an important role. So not only it is just not filling our thirst, it is also playing important role, like, you know, that it helps in regulating the body temperature of our body. How it is helping in regulating the body temperature, you know that? Like in summers, what happens? You start sweating. So when you sweat, then what happens? It is just regulating your body temperature according to the surrounding. So similarly, many reactions which are taking place in your body, the chemical reaction, that is the digestion and all, they occur in the liquid medium. So that is why the water is very important in our human body as well. So similarly, we have the great importance in case of agriculture also. As you know, the plants cannot photosynthesize in absence of water, and they may wilt, right? Or finally they may die. So that means water plays an important role. Almost every aspect, you can say, the water is this thing serving a very important reason for that substance to exist. Right. So likewise, that means it has a great importance. It is almost present everywhere. So that is why it is contributing great in the weight of the substance. Likewise, you can say approximately 75% of our weight is just because of water. Similarly, the green vegetables, what you weigh in that also, 90% of weight is due to the weight of the water. So similarly, milk, 80 to 85% weight is due to water. So that means the water is present almost in everywhere, and it is contributing in weight of every substance because it is a very important compound, right? So that means water plays a very important role. So you should also know that is striking in my mind. You will be doing in the higher class, but still you should know that Henry Cavendish was a scientist who first synthesized water, and then it was just proved after, like, he synthesized water, and it was just proved by Anton van Lavoisier, and they both said that in hydrogen, this thing water, they were first, like you can say, water exists in nature as such, but they were first to synthesize water in a lab, at lab conditions, I mean, and they were first to say that yes, the water is form of hydrogen and oxygen, and the ratio in which it is present is 2:1, that is the 2 atoms of hydrogen and 1 atom of oxygen. You know that now. So that means the Henry Cavendish and Anton Lavoisier has just made the synthesis of water in the lab possible, right. So this is how we are going to do the water, and we will be now focusing on the physical and the chemical properties, or what special properties it has, that is why it is behaving as an important substance. We will be discussing now with the physical properties, right. So, and the one more thing I would like you to know, that remember what I told you in states of matter, that states can be interconverted. That means like the water exists in 3 states: solid, liquid and gas. I will be explaining with the diagrams, it will be more clear. As you know that water occur in 3 forms: ice, water and water vapor, right. So what happens in ice? Particles are closely packed. That is why it results in the formation of ice. I am just drawing one ice. Obviously it is made up of many particles which are closely packed. And when we talk about liquid, it is just indicated by this. And when we talk about vapor, so vapor means the steam, like this, right. So you know that the states can be interconverted, like when we will heat ice, this delta sign indicates the heat. Delta means heat. And when you are heating the ice, it is getting converted to water. When you are heating the water, it is getting converted to vapor. And we know that ice to water is melting and water to vapor is evaporation, right. And similarly, when you cool it, when the vapors are cooled, they are just brought close to each other, decreasing the intramolecular space, increasing the intramolecular force of attraction, resulting in the formation of liquid, that is the water. And when the water is further cooled, it again form the ice, and the conversion of vapor to water, what you call as condensation, and the conversion of water back to ice is freezing or solidification also we can say. So that means the 3 states can be just they are interconverted, and they can be converted from one form to another. When we want to convert solid to liquid or liquid to gas, we just have to supply it with heat. And when we are converting gas to liquid or liquid to solid, we have to just decrease the temperature. That means we have to just cool it. So this is how we can just convert the states, right. So now focusing on the physical properties. So the first property what is striking in my mind, which I am going to discuss first with you, is that when you get to see, we will be discussing color, odor and taste, right. So when you get to see water, you can say a water in rivers, do you think that it is fit for drinking purpose? Or how it looks like, how clean water looks like actually. Now, does it has some color? No, it is colorless. It do not have any color. And if there is some color, so that means the water is not potable, it is not fit for drinking purpose, it contains the impurities. Because the normal water is that which is colorless. And if I talk about the odor, so that means you get a good odor, a pleasant odor. So that means you don't get that fruity smell or you don't get a foul smell. There is no such smell. So it is odorless. So pure water is odorless, right? And if I talk about the taste, so you must have drink the pure water. So how it tastes? Does it taste bitter, sour, sweet? What kind of taste you get? You get no kind of taste because it is tasteless too. Right. So that means the pure water is colorless, odorless and obviously the tasteless. The second property which I am going to discuss is electricity and heat. That you know that any substance which serve as a good conductor of electricity is obviously a good conductor of heat, because heat results as a, you can say, due to the electricity only, because when the electrons collide they just generate an heat. We know that the heating effect is an application of electricity. It happens due to electricity. So what do you think? If you take a sample of distilled water, just connect it with the wires and just place a bulb over it like I did. I am doing it in the sample, you must be doing in the physics, that I took a sample, I just put the wires in it, just connected it with the battery switch, and like this. So I am just closing this switch. What happens? So we get to see the bulb glow or not. So you will see that if this water is a distilled water, as I told you, free from any kind of minerals or germs or something like that, bulb is not going to glow. The reason being that the distilled water is poor conductor of electricity. But if in case you want to make it conductive, you have to add little amount of salt or sugar or acid, anything to it. So that means the impurities if present in water makes it good conductor, otherwise distilled water is poor conductor of electricity obviously and poor conductor of heat. And if you take a tap water instead of distilled water, it is going to conduct electricity because it contains the ions, as I told you, that is it is not a pure form of water, it do contains the ion. So whenever the electricity is passed through it, so what happens? If you take a tap water, the bulb will glow, and if you take a distilled, like if it is distilled water, the bulb will not glow. But if we take a tap water, it will obviously glow, because tap water is good conductor of electricity because it has many ions present in it. So this is how we are going to prove that, like if you get a question that prove that distilled water is poor conductor of electricity or heat, so just do that. Just take a sample, show a beaker, add the half liters of water, because if the circuit is complete, then only the bulb is going to glow, otherwise the bulb will not glow, right? So if, as I told you, distilled water is the poor conductor of electricity, and the tap water or any other water which is not a distilled form, that means contain impurities, is a good conductor of heat and electricity because it has ions in it, right? So the next property what we will be discussing, it will be the boiling point, and obviously a freezing point we will be doing along. So what do you mean by boiling and freezing point? Boiling point is that point at which liquid boils, that means it starts getting converted into the vapor. So what is that specific temperature at which the pure form of, you can say, we are taking these properties into the consideration only for the distilled water. Please keep in mind, it is not for the tap water or river water or anything, it is just for the pure form of water, distilled water. These properties are fulfilled by the pure form. So all the properties we are discussing is just about the distilled water. So if I talk about the pure water, so at what temperature it is going to change into the steam. So that temperature is called as boiling point, which comes out to be 100 degrees Celsius for the pure form. And if I talk about the freezing point, that means the temperature at which liquid is going to convert into the ice. And for distilled water again, it is a 0 degree Celsius. So if you have a sample, like if somebody tells you this, checking of boiling and freezing point serve as a good example to check that whether the sample is pure or not. So sometimes if somebody gives you certain kind of water content or something and just ask you to show that show it with certain activity that the given water or any other substance, also this activity is applicable for any substance. So if in this case we are discussing water, so that is why I am taking the example for water. So if somebody is giving you a sample of water and just asking you that prove that this is the distilled water or this thing pure for water or impure water, so just go for checking its boiling and melting point or freezing point, whatever you call that. So if it goes to be 100 degrees Celsius and 0 degrees Celsius, which is fixed for any pure substance, so that means the given sample is pure, otherwise it is impure, right? So I think it's clear. So the next property what we are going to discuss is about the dielectric constant. I think you have heard this term for the first time, dielectric constant. It just means this, it has the simple meaning, that means the water has high dielectric constant. Now the question being, what is dielectric constant? Dielectric constant is actually the ability of any substance. I'll state you with an example, then I'll tell you in a verbal form that how it is going to explain. Suppose I have a beaker and it is filled with water, right? I am adding salt to it. You know that whenever we dissolve salt in water, it gets dissolved, completely dissolved, and we get a true solution, that is the salt solution. So now what happens if we see at the atomic level, what happens actually? The water consists of H and OH ions, we know that water is not actually a molecule H2O, it is a polar molecule which has the hydrogen ion and hydroxide ions. So that means I'll draw a big beaker to make you understand in a proper manner. So suppose we have this water, right? I'm not drawing the beaker, just to make you understand. So obviously the water is in beaker, right? So we have the water, in water we have the ions, you know that. Like this we have, or you can draw it in this way. We have these kind of structures. So either you explain it with this way or this way, both are correct, right? So when you add salt to it, what happens? You get these kinds of ion. NaCl just breaks up into Na positive and Cl negative, right? So what happens actually, what do you mean by the dielectric constant, or what happens at molecular level when any ionic compound is dissolved in water? We know that ionic compound comprises of positive part and negative part. So what happens? Around the positive part, it gets surrounded by all the negatively charged atoms. We know that the negatively charged atom is obviously oxygen. So it gets surrounded by the oxygen. So we know that obviously a negatively charged particle is attracting the positively charged particle. That means it is just, you can say it is just decreasing the force of attraction between the NaCl. And similarly, if we talk about the chlorine ions, the chlorine gets surrounded by many hydrogen ions. As we know that water contains hydrogen ions as well. So what they are doing, see, the positive particles are just surrounding the negative particle, negatively charged ion which we have dissolved, and the negatively charged particle of water is just surrounding the positively charged particle of the ionic compound. So what they are doing in such a way, they are just decreasing the force of attraction between Na and Cl. So that means decreasing the force of attraction means they are just splitting Na and Cl and just making it dissolve. So that means if somebody talk about the dielectric constant, it just means the ability of substance to make anything dissolved in it, right? So water has high dielectric constant. That means it has the high ability that it can just break the force of attraction between the compounds and just it can make those substances dissolve in it, right? So due to this special property, it is acting as a universal solvent. What do you mean by universal solvent? The solvent which can dissolve as much, it is not the quantity, it is the type actually I am talking about. Universal solvent is that which can dissolve many kinds of substances in it. So due to high dielectric constant, because it is polar in nature, I think you are familiar with the term polar as well, we did in the previous periodic properties as well. Again I will be repeating for you, so just look at the board. Polar means we know that covalent molecules are not polar, there is no such charge separation, but due to difference in the electronegativity, they just tend to, the one atom which is more electronegative tend to, you can say, displace the electron pair towards itself. So what happens? When it displaces the electron pair towards itself, it acquires, I think you remember this, so it acquires the negative charge and this acquires the positive charge. So similarly it is happening, though the charge, you can say the nature is not so strong, it has it is just the partial charge, but still they have charge, and any covalent molecule which has charge become polar covalent molecule. As I told you, in water also there is this kind of charge separation, that means it is polar in nature, and this polarity helps in making it to have high dielectric constant, because as it contains oppositely charged ions, so when any ionic compound which obviously has the different charged ions is dissolved in it, the oppositely charged ions are just surrounded by the oppositely charged water molecules, so just decreasing the force of attraction. You can see that N is surrounded by negative part and chloride ions surrounded by hydrogen part. So in this way they are just decreasing the force of attraction between Na and Cl. See, again I am just making it more clear for you. See, Na and Cl earlier they were together, right? So when I dissolved in water, Na got surrounded by the negatively charged particle. Similarly, Cl gets surrounded by the positive charged particle of the water. So what happened? Their force of attraction just decreased and they become soluble in water. So that means the polarity helps water to have high dielectric constant, and the property of high dielectric constant make it a universal solvent. That means the ability to dissolve many kind of substances in it, whether we are considering the solute or a solvent, it's not like that, and we are just talking about the substance, right? So we are just taking into consideration in general the substance. So it can dissolve many substances in it, that is why it is acting as a universal solvent. Moreover, it shows one anomalous behavior. This is very important. What is this anomalous behavior? I think you understand that anomalous behavior is means the different property which it is showing, right? So what happens when we cool it, when we cool water? What happens? Obviously, when we cool any substance, the particles start moving towards each other, right? So that means when we are cooling water, water is just contracting. Water is just contracting. But this contraction is seen only till 4 degrees Celsius. Only till 4 degrees Celsius is seen. Again, I am repeating, this is very important. I am cooling water. You know that when we cool water, the water particles will start moving towards each other because they will now cool to form ice. You know that, right? So I am just cooling water. So what happens? I am just decreasing the temperature. For example, we have the temperature of 10 degrees Celsius. I am making it to 9, then 8, 9, 7. That means the particles start coming closer to each other, right? But that means when they start moving closer to each other, what is indicated by it? That means they are going to possess the high density, right? So they are just coming closer to each other. That means it has the high density. But what happens? It contracts only till the temperature 4 degrees Celsius. That means if I am decreasing the temperature 10 to 4 to 10, 9, 8, 7, 6, 5, it keeps on contracting, right? And that means it keeps on becoming more denser. But at 4 degrees Celsius, this contraction just stops and it shows an anomalous behavior that instead of contracting below 4 degrees Celsius, it starts expanding. It starts expanding. So that is why 4 degrees Celsius is that temperature at which the liquid possesses the highest density, or you can say the maximum density and maximum volume. So this is the anomalous property, that when we are cooling any substance, we know that it starts contracting. So similarly, the water contract, but this contraction lasts only till 4 degrees Celsius. At 4 degrees Celsius, or you can say after 4 degrees Celsius, it starts expanding again. So that means the 4 degrees Celsius corresponds that temperature when the water is going to have maximum density and maximum volume. So this is the reason that ice is lighter than water. It is not heavier than water. Ice is denser than water, not heavier than water. That is why ice can float on liquid. Otherwise, we know that solid, whenever any solid is added to a liquid, it generally sinks. But when we talk about the ice and the water, so ice, as I told you, that after 4 degrees Celsius, the expansion occurs. That means the density keeps on decreasing and the volume also changes accordingly. So that means the water, the maximum density of water is at 4 degrees Celsius is calculated to be 1 gram per centimeter cube, which is the maximum density which is obtained at 4 degrees Celsius. After that, it keeps on expanding and the density keeps on decreasing. At 0 degrees Celsius, after 0 degrees Celsius, when it freezes, so that means it forms ice. Again, it is less denser than water. That is the reason the ice can float on water. This is very important question, and you often get this question, why ice can float water. So just focus on the density, just related with that temperature, and just explain this cooling and this phenomena of contraction and expansion. You will get to explain everything in a correct manner then.